up, guys? Mr. Rushka here to make wanted to make a little review video so you guys could review some of the material that was frequently missed on the test. That way it helps you guys prepare for your retake later this week, and it also helps me make sure that you guys actually learned the log stuff. Okay. So we missed pretty much we actually did really well on the test except for one page. And it was stuff solving for x in log equations and exponential equations, stuff like that, okay? So there's a few different types here. I want us to talk about the first type that we learned, okay? So I'm teaching you guys how to solve for x and exponential and logarithmic stuff, okay? First is equations, right? We want to solve, let's look at number 1. We want to solve this equation for x, right? X is part of the exponent, right? This is an exponent. It's 2 raised to the x plus 1 equals 2 raised to the 9, okay? And our bases, that's the number that's not the exponent, our bases are the same. They're both 2. When that's the case, this is easy money. We just take the 2 exponents and we set them equal to each other. X plus 1 equals 9, and then to solve for x, I just need to subtract 1 from each side. So I get x equals 8, okay? All right, so that's one type, right? This one, right? The variable is in my exponent, right? 5 raised to the 4n plus 5 equals 5 raised to the n minus 7, okay? And our bases, right, the number that's not the exponent, they're the same. So I just set, oh, what the heck? So I just set those 2 exponents equal to each other, and then I have an Algebra 1-like equation that I can solve for n, okay? So 3n plus 5 equals negative 7, minus 5, minus 5. I get n equals negative 4, okay? All right, the next type you have, this is similar. This is equations that don't have a common base, so I'm going to write in the exponent here, right? I have my variable is in the exponent. It's in the exponent. I don't have a common base yet, right? 6 and 36, they're not the same number, okay? But what I can do is what I do know about 6 and 36, they're not the same number, but they're both powers of 6, right? 6 equals 6 to the 1. I can rewrite 6 as 6 to the 1. I don't really need to do that. And I can rewrite 36 as 6 squared, okay? So when your 2 bases, right, that's the number that's not the exponent, when your 2 bases can both be written as powers of the same number, you want to rewrite them as powers of that number. So 6, I have 6 to the 2x minus 10. I'm just going to leave it like that. 36, I rewrite as 6 to the 2. Okay, right? 36 equals 6 squared. Now, look what I have. It reduces to just the easier problems up here. Now my bases are the same. I can just set the 2 exponents equal to each other and solve for x. Okay. There you go. So there's my answer. Okay, so that's the second type of equation. Let me do another one. Some of these can get a little harder. Right, fractions, right? 7 and 1/7. It might not seem like it at first, but my bases here are both powers of 7, right? 7 equals 7 to the 1. 1/7 equals 7 to the negative 1. Okay, don't forget negative exponents. So I have 7 to the 4x plus 11 equals 7 to the negative 1. Now my bases are the same on both sides, right? They're both 7, and I can just set the exponents equal to each other. There you go. All right. I want to find an example. Here we go, right? Here's another example. I want to show you guys this. So 16 and 8, right? My bases aren't the same, but they're both powers of 2, right? 8 equals 2 cubed, and 16 equals 2 to the 4th. So I'm going to rewrite both of these, okay? I need to put these in parentheses when I rewrite them, okay? For this example, I have 16 equals 2 to the 4th, and that's still raised to the 3x, okay? 8 equals 2 cubed, and all of that is still raised to the x plus 2. All right? Still raised to the x plus 2. So what I do here then, right, how do I simplify my exponents? I have a problem here, right? I have a number, I have a base, 2, and it has two exponents, a 4 and a 3x, right? How do I combine those when there's two exponents? I multiply the two exponents together. So 2 to the 4 raised to the 3x becomes 2 to the 4 times 3x, or 2 to the 12x. Okay? 2 to the 3 raised to the x plus 2 becomes 2 to the 3 times x plus 2, right? So now we have an equation that's just, sorry, I should have made that just a 12x. Yeah, here. Yeah. So it becomes 2 to the 12x equals 2 to the 3 times x plus 2. Okay. Now, again, my bases are the exact same now. I can just set the exponents equal to each other. I'm going to distribute 3 times x plus 2 is 3x plus 6. Subtract 3x from both sides. 9x equals 6, or x equals 6 over 9, which is 2/3, okay? And again, I can always check my work by plugging in my answer back into the original problem they gave me, okay, and making sure the two sides equal each other when I plug it back in, okay? You actually have to do that for some of these, okay? All right, then what really threw us for a loop was going down to the 9.8 notes that you guys were supposed to watch a video over. I saw the video had 71 views. That's pretty good. Just please make sure you watch it, okay? If you didn't watch it, that kind of explains some of our mistakes, okay? Now I'm going to look at a similar equations, okay? So 3 to the x equals 8, okay? Right? The bases aren't the same here, right? The bases aren't the same, so let's rewrite them as powers of a common base, okay? Oh, wait. They can't be, okay? So two problems here. They're not the same base, right? 3 and 8 are not the same number. Uh-oh. Okay, 3 and 8 are not the same number. Okay? They're not both powers of the same number, right? 3 equals like 3 to the 1, right? You cannot write 8 as 3 to the anything, okay? Right? I can't get a common base by rewriting stuff as something squared or something cubed, okay? I got a problem, okay? So I've got whenever your variable, so pay attention. Whenever your variable is in the exponent, right? I have 3 raised to the x equals 8. Whenever the variable is in the exponent and I can't get my two bases to be the same, when I can't do that, I have to use a logarithm, okay? What I do is I look at the base of the exponent where x is, okay? So x is on the exponent on the left side. The number that's not the exponent, that's the base. The base is 3. I'm going to do a log base 3 on both sides of this equation, okay? So let me scratch out that a real quick. It's getting in my way. Okay. So I'm going to do log base 3 on the left, okay, equals log base 3 of 8, okay? I can write a log base 3 in algebra. You're good, if you don't mind me filming. Okay. I'm going to write a log base. I can write a log base 3 in algebra as long as I do it on both sides of the equation, okay? So log base 3 of 3 to the x equals log base 3 of 8, okay? What happens is when I have a logarithm, and the base of the log, the small number on the log, is the same as my big number, those are going to cancel, okay? I'm just left with x, so I get x equals log base 3 of 8, right? And I can plug that into my calculator, right? We plug that into our calculator by doing log 8 divided by log 3, right? We don't have a log base 3 button in our calculator, but we do have just a regular log button, so we do it like that, okay? So again, let's look at another one. Something like this, okay, part F. 6 to the 4x minus 5 equals 18, right? My bases aren't the same, and I can't get my bases to be the same, right? I can't rewrite both of them as powers of a common base, okay? So what I don't do here, a lot of people did this, I do not divide by 6. You don't do that. Don't do that. No, bad, okay? I look where x is in the exponent on my 6 here. So I do a log base 6 of both sides. All right? So what happens, the log base 6 and the 6 cancel. I get 4x minus 5 equals log base 6 of 18. Okay? And then I solve this for x, right? Get x by itself on the left. Treat the log base 6 of 18, treat this as just one number. So add 5 to both sides, add 5. You get 4x equals, let me make my pencil a little skinnier. Log base 6 of 18 plus 5, divide by 4. Okay, divide by 4. Right, and then rewrite this in your calculator as log, just regular log 18 over log 6 plus 5 divided by 4. You can put that in your calculator. That'll give you the right answer, the correct answer for x, okay? So that's something we really struggled with, okay? Let's go on to a different type of equation. Let's go on down to these, okay? Log base 2 of x plus 2 equals 4, okay? Log base 2 of x plus 2 equals 4. What's different about this now x is not stuck inside of an exponent. Now it's stuck inside of a log. It's stuck inside my log here, okay? So most of the time, what I want to do when that's the case, I've got one log on the left side, I've got a 4 on the right side, okay? What I want to do is how do I want to explain this? I'm going to do a 2. I'm going to write 2, and I'm going to take this log on the left side. I'm going to turn that into an exponent. So I'm going to have 2 raised to the left side, so 2 raised to the log base 2 of x plus 2. And I've got to do that on both sides. That equals 2, again, 2 raised to the 4, okay? So I wrote 2 2's down, and then I copied down both sides of my equation as exponents in this new equation that I just wrote down. And I can do that as long as I do it on both sides, okay? What happens is when you have a number raised to a log that has the same base, right? 2, this is a 2 right here. This is a log. It's raised to a log base 2. What happens is those cancel. You get x plus 2 equals 16, or x equals 14. That'd be your answer. For these, when you're solving a log equation, when at the beginning of the problem x is in the log, you have to plug in your answer to check it, okay? That's because if I were to get like a negative number in here, then I would have no solutions. So I have to check log base 2, what is that? 14 plus 2 equals 4. Log base 2 of 16 equals 4. And then if you plug log base 2 of 16 in your calculator, you'll find that it equals 4. You get 4 equals 4. We're good, okay? All right, let's do another one. So these are similar. These are similar, right? I have x stuck inside of a log, okay? Common mistake on the test was a lot of people saw, okay, x is stuck inside of a log base 4. I'm just going to do 4 raised to the left side equals 4 raised to the right side, right? We're treating both sides of the equation. They become exponents, okay? Can't do that yet, okay? What you need to do, what's different about this problem is I have 2 logs now. I have 2 logs, and they're on the same side of the equation, okay? when I have two logs on the same side of an equation, before I can start solving for x, I need to combine the logarithms, okay? So these two logarithms have a minus in between them, so it becomes log base 4, you copy down the same base, of 12 divided by x. Okay, that equals 3. Now I have what I just had in this problem over here, right? I've got an equation with a logarithm on one side and a number on the other, okay? So I'm going to do 4 raised to the left side. So what happens is both sides of this equation become exponents in this equation down here. So 4 raised to the log base 4 of 12 over x equals 4 raised to the 3. Okay? Again, guys, whenever you have a number and you raise it to a log exponent, an exponent that has a logarithm in it, and the base is the same as that number, okay? So I have 4 raised to a log base 4. The 4s are the same. Those are going to cancel. I'm left with 12 over x equals, what's 4 cubed? 64. Equals 64, okay? And then multiply both sides by x. 12 equals 64x, okay? Or x equals 12 over 64, which is 6 over 32, which is 3 over 16. Okay? And again, I have to take this 316 and plug it back into my equation up here. All right? You can never have a negative number. If this were a negative, then I would have to write no solutions. Luckily, it's positive 3 over 16. This solution's going to work. Okay? So that's good. One other thing I do want to go over with you guys, there is one on there. It's something like, if I have like log base 5 of x plus 12 equals log base 5, let's do x minus 2. Okay? There's something on there that looks like this, okay? So both sides are a logarithm. X is stuck inside of a logarithm. Okay, the bases are the same. There's one log, just one log on each side. Okay, so up here, right, this first problem we had one log on one side. Over here we just had 2 logs on the left side. Here, what's different about this problem down here, let me move my head. It's got one log, or it's got one log on each side. They have the same base, the small number's the same. So all I have to do here is I just set whatever's inside the logs equal to each other. Okay? I do x plus 12 equals x minus 2. Okay? And then I solve that. Minus x, boom, boom. 12 equals negative 2. Oh no, that's never true.
Already forgetting stuff. Are you recording yourself?
Yeah, you're good though.
Say hi to everyone for me.
Yeah.
Mr. Miller.
Mr. Miller says hi.
Sorry about that.
No, you're good. Are you proud of me for teaching Algebra II?
I'm just stunned. You're recording something.
So I get no solutions for this one, okay? But whenever you have 2 logs equal to each other, for this particular one, I got no solutions. It's not always no solutions, just for this particular one. And then one more I wanted to talk about. Let me look down here. We really struggled with continuously compounded interest. So we did great for regular compound interest, okay? So let's do an example problem of that. Okay, here we go. So we've got, make sure it looks good. Find how long it takes a $3,500 investment to earn $400 in interest if it's invested at 8% compounded semi-annually, okay? So the word compounded, that tells us I need to use my this is my standard compound interest formula right here. This is my standard compound interest, okay? Standard, I mean just regular run-of-the-mill, what we've been doing all year, okay? What we did back in August. All right? I know I'm going to use this original compound interest formula because it says semi-annually, okay? If it says semi-annually or monthly or quarterly or whatever, If it says semi-annually, monthly, quarterly, anything but continuously. If it says compounded, then the word after compounded is anything but the word continuously. We use the regular compound interest formula, okay? So I'd plug in, let's see, if I'm earning $400 in interest, I initially invested $3,500. My final account balance is going to be $3,500 plus $400 plus that interest, which is $3,900. And that's going to equal $3,500. That's right. That's my initial investment plus times 1 plus R. What's R? 0.08. Semi-annually means twice a year, so my N is going to be 2 to the 2 times how many years? We're solving for T. Okay, this is a good review. Okay. So again, right, what I want to do here is I want to combine. I'm going to get my calculator. Let's simplify whatever's in my parentheses. So I get 1 plus 0.08 divided by 2. So this becomes 3,900 equals 3,500 to the 1.04 raised to the 2t. Okay. What's going on here is I'm solving for my variable. My variable, right, it's stuck inside an exponent. It's the exponent for 1.04. So first I want to get the 1.04 by itself. So I have this 3,500 here I got to deal with. This is a 3,500 times 1.04 raised to the 2t. So to undo multiplication, right, Algebra 1, you do division. Okay, so those two zeros, we get 39 over 35 equals 1.04 to the 2t. Now look what I've got here, guys. My variable is stuck inside of an exponent. Okay, it's stuck inside of an exponent. Are my bases the same here, right? 39 over 35, right? That's not the same as 1.04. Let me check. There's no way. There's no way. Okay, yeah, it's not. They're not the same. Okay. I can't write them, right? I can't rewrite them to make them the same like I could some of my earlier problems. So what do we do when that happens? Right? We look at, so 2t is in the exponent on 1.04. Right? The number that it's the exponent of, we do a log base that number. So if that sounds confusing, let me restate that. So I have 1.04 to the 2t right here. My base is 1.04. The base of this exponent is 1.04. So that will also be the base of the log that I insert on both sides. Right? I can insert a log, whatever kind of log I want. It can be base 100,000 if I want, base 3 trillion. I just have to do it on both sides. Okay? So what happens, right? I have a log, the small number and the big number, and my log are the same. Those are going to cancel. That leaves me with 2t on the right. Other side is log. If you want to put this in your calculator, you change it to log 39 over 35 divided by log 1.04. That equals 2t. And then last step, right, we got to get the t by itself, so we're going to divide by 2. Okay, so we get t equals log 39 over 35 divided by log 1.04. All of that divided by 2. That'd be my answer. You put that in your calculator. Okay. All right. So we do, it's just the typical classic compound interest formula whenever it says compounded semi-annually or monthly or quarterly or whatever, okay? If it says, let's go down to another problem here. Look at this. Find how much Dana has after 12 years if $1,400 is invested at 8% interest. If it says compounded continuously, we got to slam on the brakes. We use a whole nother formula, and it's actually easier to use. It's just A equals P times E to the rate times time. Okay? So A is, again, that's the same thing as with my regular compound interest formula. It's your final balance. They want us to solve for that, so we're just going to write A. P, her initial investment was $1,400. E is a number in your calculator. It's kind of like pi. Okay? And then we raise that to the rate, so 0.08 times time, which is 12 here, okay? So that's when I I like to call it the PERT formula. It looks like the word PERT, okay? It's a shampoo brand, if any of you use PERT shampoo. So if it says continuously, compounded continuously, you use this A equals PERT formula, P times e to the RT. So in your calculator, you do, I think on our review days, we knew how to do this. 1400 times E, hit the E button, hit the second button, and then the division symbol on your calculator. 0.08 times to the E, and it's E raised. So E exponent 0.08 times 12. Oh, that's great. It's a great interest rate. Get 3,656.38. Boom. Okay, so little recap. I don't want to make this video too long. If my problem says compounded continuously, I use the A equals PERT formula, okay? Mnemonic device, right? PERT is a brand of shampoo, right? You should continuously use your shampoo every night, okay? I don't know, terrible. But maybe you'll remember that terrible joke, and then you'll remember, okay? Up here, if it says compounded semi-annually or monthly or quarterly, any word but continuously, you use the classic compound interest formula that we've been using. All right, so see me if we have any questions. Yeah, take care.